Now we move forward with working capital management decisions on inventory. Now, the peak of this discussion on inventory would be managing your inventory costs to a minimum, because our goal here is to maintain just enough amount of inventory without hurting our relationship with customers. So the costs that are involved in maintaining our inventory with the purchase price, of course, the production cost if we are a manufacturing company, ordering costs, the cost to place one order. So we have carrying costs, the cost to maintain our inventory in our current facility. Then we have stockout costs. Actually, this represent the opportunity cost of not having that inventory available. Of this inventory cost, stockout cost is the cost that we do not represent in our financial statements, but are actually relevant in decision-making purposes because they could have been earnings, but we have not earned as a result of the inventory item not being present within the company premises. Now, we have various inventory management models in order to address our requirement to properly manage inventory quantities. We have the ABC model. Actually, ABC model classifies inventories into three classes: Class A, Class B, and Class C. Class A inventories would be the ones that require more attention because they are the high-valued items, or the items that are critical in our business operations. Class B will be for middle value, and Class C for the low value items. Actually, ABC model does not stop there. Once we classify them as Class A, Class B, and Class C, we assign management models to these different classes. Usually, Class A inventories are the ones with the more complicated inventory management models than Class C. Usually, we use two-bin system for Class C, wherein once the bin A has no stocks available, we replace bin A with bin B, and then we replenish bin A by ordering. Then once bin B has no stocks available anymore, we replace it with the with the bin A again, since it is already restocked. And then we will have to order again for bin B. That is the two-bin system. Order cycling method establishes schedules of periodic or regular review of quantities on hand to determine the number of units to be ordered and bring the stock balance at a desired level. So usually when we do order cycling, we do this with higher classes of inventory, those items which are hard to maintain as well and hard to keep in the premises, but we do not want to have stockouts. So we need to determine the ideal inventory quantity that we need to maintain. Min-max method, the minimum inventory level, serves as the reorder point, and we have a safety stock in case of stockouts, and the maximum inventory would be the order quantity and the safety stock, because you would the minimum inventory would be the reorder point, and by the time the inventory arrives, the order arrives, the reorder point is diminished by the amount of the daily requirements from the date of the reorder to the date of the arrival of the restock. Now, economic order quantity is the quantity, inventory quantity, where total ordering cost would be equal to total carrying cost, and inventory cost would be at the lowest. So EOQ in units would be this formula. EOQ in pesos would be this amount. So, and then economic production run, if you are manufacturing the products, would be this one. The consideration would be the setup and the carrying cost. While EOQ, if we have back orders, would be this one. So let's now compute this problem. Jenna Company sells 20,000 radios evenly throughout the year. The cost of carrying 1 unit of inventory for 1 year is 8 pesos. And the purchase order cost per order is 32. What is the economic order quantity? Actually, so here we have our EOQ would be equal to square root of 2 multiplied by sales multiplied by ordering cost multiplied by carrying costs. Actually, when I present this, I always say it that way. 2SO over C. So EOQ would be square root of 2 multiplied by 20,000 multiplied by the ordering cost of 32 over carrying cost of 8. So using our calculator, 2 multiplied by 20,000 multiplied by 32 divided by 8 would be 160,000. Square root of that would be 400 units or 400 radios. Now we carry on and tackle about the ideal inventory quantity to be maintained in our operations. So the thing here is we need to have a reorder point. What is a reorder point? That is the inventory level where a purchase order should now be placed. Reorder point is composed of the lead time quantity and safety stock quantity. Lead time quantity pertains to the quantity that you would require from the time that you reorder up to such point when the order arrives. So of course, when we usually when we order today, it will not arrive until X number of days. So that number of days would be your lead time. So your average daily requirement multiplied by lead time would be your lead time quantity. Now, safety stock is your allowance if in case there are variations or fluctuations in your requirements for your daily operations from the time that the order is placed up to orders are received. So safety stock is composed of 2 items: safety stock in time and safety stock in usage, which can be solved using the formula presented herewith. Maximum inventory level actually is the safety stock quantity added to the order size. Why do we need the maximum inventory level? Actually, we need to consider the maximum inventory level in considering your costs in maintaining the inventory quantities. Now, let us answer this problem. So, the following data relate to inventories for a given year of May Company. So, the EOQ is 7,500 units. Cost to place one purchase order. So, total cost to place purchase orders for the year. And then cost to carry 1 unit for 1 year. What is the estimated annual usage in units? So, the formula of EOQ would be square root of 2SO over C. Now, we have our EOQ of 7,500 units is equal to square root of 2 multiplied by the demand actually is not here, the sales, then multiplied by the ordering cost, which is 75 over carrying cost of 6. So that is 7,500 is equal to square root of 2 times 75 is actually 150 d over 6. So we square the entire equation so that we can remove the square root. So 7,500 squared is 56 to 50 is equal to 150d over 6. So multiply that by 6 and then divide by 150. That would be your demand, which is 2,250,000. Let's answer another problem. Assorted Discs sells 200 discs per week. Purchase order lead time averages 3 weeks. Based on most updated calculation, the economic order quantity is 450 units. What is the reorder point? So the reorder point would be the lead time quantity, add safety stock quantity, but we do not have safety stock quantity here, so we just consider the lead time quantity, which is 200 multiplied by 3 weeks, or 600 discs. Now we go with optimal safety stock. What is the optimal amount of safety stock that we need to maintain? So that is the quantity where the sum of carrying costs and stock out costs are at lowest. So we need to consider the carrying cost of that safety stock, because ideally, if we do not want to have stockouts, we need to maintain very plenty quantity of inventory. But that is not advisable, since carrying costs is the trade-off of that. Carrying costs for safety stock would be the safety stock multiplied by carrying cost per unit, and expected value of the stockout cost would be stockout cost multiplied by the probability of the stockout. So if that is not available, that is stockout units multiplied by stockout cost per unit multiplied by the probability. So to further illustrate that, let us answer this problem. Each stockout of product T sold by XTM Incorporated costs 8,750 per occurrence. The carrying cost per unit of inventory is 250 per year, and the company orders 1,500 units of product 24 times a year at a cost of 5,000 per order. The probability of stockout at various levels of safety stock here is, we have the safety stocks here and the probability of stockout. What is the optimal safety stock level? So for here, we have the safety stock, which is 0, 100, 200, 300, and 400. Then the probability of stockout is at 0.5, 0.3, 0.14, 0.05, and 0.01. Then our stockout cost here would be, the stockout cost is 8,750 multiplied by the number of occurrences, which is 24. So we would have 8,750 multiplied by 24, that is 210,000. So the total cost actually for a safety stock of 0 would be, total cost would be 210,000 times 0.5 or 50%, that is 105,000. Next would be for the 100 units of safety stock, we have your 100, that is 210,000 multiplied by 0.3, that is 63,000 for the stockout, plus the carrying cost of 100 multiplied by 250 per unit, so that is 25,000. Your total cost would be 63,000 plus 25,000, that is 88,000. Next would be for 200 units, how much would be your carrying costs here? First would be for the stockout cost, that is still 210,000 multiplied by 0.14, we have 29,400, And your carrying cost would be 200 times 250, that is 50,000. So we have 79,400. Then next would be 210,000 times 0.05, that is your stockout cost, 10,500, and then plus, that is 300 multiplied by 250, 75,000. We have 85,500. And finally, for a quantity of 400 units of safety stock, that is 210,000 multiplied by 0.01, that is 2,100, plus 400 times 250, we have 100,000. So we have 102,100. As mentioned, the safety stock that we need to maintain would be the layer or the units of safety stock where the total cost would be lowest. So that would be at 200 units. So that would be your safety stock, 200 units.